Welcome to Study Loop.
Okay, let's begin solving problem 32. Before we solving it, I want to quickly go through the background about the spectrum of two isotopes. You know that the different spectrum of different atoms came from the hopping of their shell electrons outside. For if this hydrogen atom, this is the nucleus, and this is the energy levels 0, 1, like this. Hopping of the electrons will emit photons. If there's a deuterium nuclei, you know that they have one extra neutron there, so the energy levels will be slightly different. So the electron, when it's hopping to somewhere, it will, you know that it will emit a different wavelength photons. So this is the background. So now let's set it up. What we have is two different wavelengths. One is lambda for hydrogen. The other is lambda prime for deuterium, and the lambda equals 656.45 nanometers, and the lambda prime is 656.27 nanometers. And to solving the question A, we need to apply the equation 3615. The resolution power R equals lambda over delta lambda. Here lambda is our bigger wavelength lambda here. And the delta lambda is actually the lambda minus lambda prime. So and R, it also equals the N times M. Here we need to interpret the N and M here. So M is just the order of our maxima. For example, here we are asking the second order, so M equals 2 in our case. And N here is the one we want to calculate, and N is the how many slits on the gratings. So we simplify this equation, and we get N equals lambda over 2 times lambda minus lambda prime. And we just plug the value and the lambda prime to this equation. And finally, we'll get N equals 1823. Okay, so this is the question A here. Now let's move to the part B here. The part B provides basic information about the separation D of each between each slit. It's said for every millimeters we have 500 slits, so which means D equals 1 over 500 millimeter. And of course we can convert the unit to the meters. And what we also know is the equation 3613. Let me write it down. Separation D times sine theta equals M times lambda here. So if we want to get the angular position difference at the second maxima, which means m equal 2, this is what we learn. So we will get theta equals theta equals arc sine 2 lambda or d here. The next thing, so we don't have theta here. So the next step is just to plug in the value of d here and 2 different lambda here. And for we learned that we have lambda equals 656. Oh. 0.45 nanometers equals 656.45 times 10 to minus 9 meters. And we also have lambda prime equals 656.27 times 10 to minus 9 meters in the unit meters. So we just plug in the lambda or lambda prime here. So what we will get theta equals 41.2 upon 0 to 97 degree, and theta prime. Once we get plug in the lambda prime is here, we will get theta prime equals 41.016 in degrees. So the angular difference is there. Theta equals theta minus theta prime. It equals 0.137 degree here. So here what we need to notice is the difference how of the resolution, how they resolve on the two different lights, because at the same order maxima, they have the maxima have a slightly difference. They have a slightly difference. So which means if you have the lambda here, I mean the maxima, but there's slightly shift for the lambda prime. So, and then we can find the difference on the patterns there. Okay, so that's all of this problem. Thank you.